Hey there, this is your host, and welcome to this introductory chapter of our brand new course, Understanding Body Mechanics. This course will take you through the journey of body mechanics all the way from cells to systems. We'll explore how the human body moves, the factors that affect movement, and we'll even look at how machines and technology are designed to move like us. So if you ever wondered why it is that we move the way we do, or how robots can be programmed to mimic human motion, then this is the course for you. In this first chapter, we're going to lay some groundwork by looking at what body mechanics actually is. Body mechanics is the study of how the body moves, and it's an interdisciplinary field drawing knowledge from biology, physics, and engineering. It is also an extremely important one because understanding body mechanics allows us to improve our quality of life. For example, knowing how the joints in our fingers work allows engineers to design better keyboards so that we can type more efficiently and reducing the risk of injury. Understanding how our muscles contract and relax lets us develop exercise programs that are tailored to the specific needs of different people. And understanding how the brain controls our movements helps doctors diagnose and treat disorders that affect our motor control. Body mechanics is relevant to all of us because it affects how we perform everyday activities, how we play sports, how we work, and even how we age. In fact, you might be sitting in a chair right now with your legs crossed, just like me. But that's not necessarily what everyone does when they sit down. In Indonesia, for example, it's common for people to sit in a squat position, which has a completely different set of biomechanical considerations compared to sitting in a chair. And both ways of sitting are totally fine. There isn't a one-size-fits-all approach to body mechanics. It all depends on a variety of factors, including the activity, the environment, and the individual person. Now let's look at a few of these factors in more detail, starting with the activity. Activities have a wide range of movements that can be broken down into two main categories: gross motor skills and fine motor skills. Gross motor skills refer to larger movements of the limbs, such as walking, running, and jumping. These movements are typically initiated by the large muscles in the trunk and the limbs. On the other hand, fine motor skills involve smaller, precise movements of the hands and the fingers, such as picking up a pencil or threading a needle. These movements are controlled by the smaller muscles in the hands and the fingers. So let us say you were going to design a training program for a ballerina who wants to improve her technique. Her training would focus heavily on improving her fine motor skills, so that she could maintain the precise control needed for the small, intricate movements required for ballet dancing. In contrast, a football player would require a different training program to improve their gross motor skills, such as kicking the ball with full power. Next, we come to the environment. One key aspect of the environment is the surface on which we move. Different surfaces can significantly impact how we move. For example, we need to use very different sets of muscles to move on a flat surface versus moving up and down stairs. This is because the terrain affects the direction and the speed of our movements, requiring us to adjust our muscle activity accordingly. For instance, when we go up the stairs, we need to use our leg muscles to exert greater force than when we go down the stairs. That's why stair climbing can be a great workout, providing a challenge to our muscular system that it doesn't encounter on a flat surface. Another aspect of the environment is gravity. When we're on Earth, gravity pulls us towards the ground, and our bodies have evolved to move efficiently in this environment. However, when astronauts go to space, they experience very low gravity conditions. This can make simple tasks, such as walking, incredibly challenging, because they need to be careful not to float away. To counteract this, astronauts train extensively in environments that simulate low gravity, such as in zero-gravity facilities on Earth. By doing so, they can prepare their bodies for the unique challenges of moving in space. Then we come to the third factor, the individual. There are a lot of variables here that can affect how someone moves. Let's start with our skeletal structure. You may be thinking, well, we all have the same basic skeleton, so this shouldn't make too much of a difference, right? Well, hold on. You see, although our skeletons share common features, there's a lot of variation in how our bones develop and connect with each other. For example, some people have a larger rib cage while others have longer arms. Even seemingly minor variations in our skeletal structure can lead to differences in how we move. Now let's talk about muscle strength and muscle endurance. Muscle strength refers to the maximum force a muscle can exert in a single effort. Muscle endurance, on the other hand, refers to the ability of a muscle to sustain repeated contractions without getting fatigued. These two factors can vary significantly among individuals, which can affect how we perform physical tasks. You see, if someone has greater muscle strength, they'll be able to lift heavier weights than someone with lower muscle strength. Similarly, if someone has better muscle endurance, they'll be able to perform repetitive tasks for longer periods than someone with lower muscle endurance. And finally, our nervous system plays a big role in determining how we move. You see, our brain sends signals through our nerves to our muscles, telling them to contract and relax. However, the efficiency of these signals can vary depending on factors such as age, health, and even practice. When our nervous system is working efficiently, we can perform coordinated and precise movements. However, if our nervous system is compromised, we may experience delays or errors in our movements, leading to a lack of coordination and control. For example, multiple sclerosis is a disease that affects the nervous system and causes muscle weakness, fatigue, and loss of coordination. This can make simple tasks, such as walking, very challenging. So these are just a few of the factors that can influence how we move. Remember, there's no one-size-fits-all approach to body mechanics. Each person is unique, and we all move in different ways. So far, we've explored gross and fine motor skills, the effects of the environment, and the influence of individual factors on movement. Now let's put all of this together and apply it to real-life scenarios. Let's consider two activities, typing on a keyboard and playing the piano. Both activities require fine motor skills. However, the specific demands of each activity differ. Typing involves repetitive and fairly forceful keystrokes. Playing the piano, on the other hand, requires more nuanced and delicate keystrokes. Therefore, the specific muscle groups involved and the level of force exerted will vary between the two activities. The same is true for gross motor activities like walking. Walking on a flat surface is different from walking on uneven terrain. The latter requires more balance and control, placing greater demands on the vestibular system and the proprioceptive system, which are responsible for maintaining balance and spatial orientation. These examples illustrate that even activities that may appear similar can have different mechanical demands, which is why it's crucial to understand the underlying principles of body mechanics. By doing so, we can develop better strategies for improving our movement efficiency, preventing injury, and enhancing our overall quality of life. As we continue our journey through this course, you'll have the opportunity to delve deeper into the fascinating world of body mechanics. You'll learn how the structures of the human body are organized and how they work together to enable movement. You'll explore the mechanical principles that govern human motion and discover how these principles are applied in various fields, such as healthcare, ergonomics, and sports. Our aim is to not only provide you with theoretical knowledge, but also practical skills that you can apply to real-world situations. Whether you're interested in improving your own physical performance, designing better products or services, or simply expanding your understanding of the human body, this course has something to offer everyone. So get ready to embark on this exciting journey of discovery. And remember, the more you put in, the more you'll get out. If you're active and engaged in the learning process, you'll get so much more out of this course. So don't hesitate to ask questions, participate in discussions, and apply what you learn to your own experiences. Thanks for watching.